All right. So like I said, 7.1a, taking a look back at solving multi-step equations. Here's our goal for today's lesson. This is what we're going to be able to do by the end of this lesson. We're going to be able to get a variable isolated, which just means by itself, on one side of the equal sign. That's our goal. That's what we're trying to do here. Yes? Yeah. Need something right now? Don't worry about that. Make sure you listen, understand it. So if you look at any of these problems and you go, I don't even know what to do, this is your answer. This is what you're trying to do. You're trying to get a variable or a letter, like x, isolated by itself on one side of the equal sign, right? That is our goal, and we're going to accomplish that goal by using inverse operations. And inverse operations are pretty simple. There's 4 operations that we have: addition, subtraction, multiplication, and division. So we have 2 sets of course, inverses. We have addition and subtraction. And then we also have multiplication and division. So those are our inverse operations. The inverse of addition is going to be subtraction, and it works the opposite way too. The inverse of subtraction is going to be addition. The inverse of multiplication would be to divide, and the inverse of dividing is going to be to multiply, right? So they work both ways. That's our inverse operations. And each time you get to a problem where you're being asked to solve for x or isolate x, either of those, what you're going to want to do is ask yourself, what operations are we performing on the variable? Now that's a really long, complicated question to ask yourself every time you see one of these problems. So let's shorten that. We can say, what are we doing to x. So when I say, what are we doing to x? That's just the shorter way of saying, what operations are we performing on this variable? Are we adding something to our variable? Are we multiplying our variable by something? Who knows? We'll see. If you start by asking yourself this question, it'll help get the ball rolling and hopefully help you follow through with the rest of the problem, as long as we can keep in mind our inverse operations. So let's take a look at an example here. We'll go example A. And let's call example A, let's say it's going to be x plus 4 equals 7. So, we got x plus 4 equals 7. Again, a lot of you may be able to look at this and immediately know what our x is equal to, right? What's our x going to be equal to here? 3, right? 3 plus 4, that's going to give us 7. That would be a true statement. Now, sorry. How do I want to say this? Even the ones that you can do in your head, I still want to see this work for on this worksheet, because the more that you do it, sorry, my brain is like not working right now. Sorry. Anyway, let's just get into it. Sorry, well, I'll come back to that thought. So we have this equation, right? We're going to ask ourselves, what are we doing to x? And really, we're saying, what operation are we doing to x, right? So right now, what are we doing to x? We're adding, right? We're using addition. We see that plus sign with a 4 next to it. That's what we're doing to x. We are adding 4. So let's say we see we are adding 4 to x. The inverse of this would be to do what? What do you guys think? What would the inverse of adding 4 be? Subtracting 4, right? And then we have to add in here that we're not just subtracting 4 from that 4. We're doing it to both sides of the equal sign. So maybe like, why are we doing all this writing and all this thinking if we know that the answer is 3? Because you're not always going to get an equation where you're going to know the answer right off the bat. And we'll see one of those equations here in a little bit. So here's what I want you to do. This may be familiar to some of you depending on your teacher last year. But we're going to take this equal sign here, right? And the equal sign is the pivotal point of our equation. That's where we have the left side of our equation and the right. Basically, the equal sign divides our equation in 2 parts. So what we're going to do is we're going to draw a line through it and divide our equation into its 2 separate parts, the left side and the right side. That's the first thing you want to do before you even mess around with the numbers. Draw a line through your equal sign just like this. on your worksheet today, I need to see this set up exactly how we're doing it. Okay? I'll be coming around to help you guys at the end. But if it is not in this setup, if it doesn't look exactly like this, I'm going to have you erase it and redo it. It needs to look exactly like this. Okay? And we have to keep everything in line. So here's what we're going to do. We're adding 4. The inverse of that's going to be to subtract 4. So let's do that. Let's go ahead and subtract 4 from 4. But equations are like scales, right? I'm not talking about a digital scale where you step on it and then a number shows up. I'm talking about scales that actually have to be balanced. Like if you're a Libra, you know what I'm talking about. That's your sign is the scale. If you have 2 things in a scale, right, and you take one of them out, now the scale is not even. One of those sides goes down, one of them goes up. Our equations work the same exact way. If we have this nice balanced equation here, x plus 4 equals 7, and then we subtract 4 from one side, now we don't have a balanced equation. It's all out of whack. But if we subtract 4 from both sides, then things come back into balance. So when we do the inverse operation, we have to make sure every single time, whether we're adding, subtracting, multiplying, or dividing, that we do it to both sides. After we write down those minus 4s, we're going to draw a line under our whole equation, like a typical subtraction problem would look. Then we're just going to go through and simplify. What's positive 4 minus 4 going to give us? 0, right? So we're just going to cross those out. Those 2 terms cancel each other out. Now let's go ahead and rewrite our equal sign down here. Keeping it in line with the equal sign, not moving it over to the right or to the left, keeping it exactly in line with our equal sign. These 4's canceled out, right? But what do we still have on the left-hand side? X, right? We're going to keep that X once again directly in line with our original X. We're not moving it over. We're keeping it in line, and we're leaving this space here blank. And the reason for this, the reason why I'm so specific about it needs to be this exact way, is because this is the way that if you can ingrain it into your brain and learn how to do it this way, it's going to help you so much in the future, because you're going to be able to keep organized and follow exactly what you're doing step by step. Okay? So it's not just me telling you what to do just for the sake of telling you to do it. It's to prepare you guys better, essentially. Then we solve the right-hand side. These don't cancel out. What's 7 minus 4? 3, right? Now, what was our goal here again? To get the variable isolated, right? Is our variable all alone on one side now? Yes, it is. That x is all by itself on the left. There's no more plus 4 next to it. So we can say that that is our answer right there. And that's the answer we came up with at the very beginning, right? We saw that blank plus 4 equals 7. Well, that blank's got to be a 3. This is how we're going to go through and find out specifically what that number is without doing any guessing. Okay, we don't want to guess. Let's go down to B. Example B is going to look something like this. 2x equals 12. $2x is equal to 12. And I'll go ahead and ask you guys, what are we currently doing to x? We are multiplying. That's exactly right. 2 right next to the x, that's multiplying. So we see that we're multiplying 2 by x so the inverse would be to do what? Anyone have an idea? Divide, exactly. The inverse of multiplying by 2 would be to divide by 2. On both sides. We got to remember to always do it to both sides. So again, first thing, draw a line through your equal sign just like that. That should be the first thing that you do on each of these problems. All right? If we don't know which side we're moving what number to, right? If we maybe split the equation on a plus sign accidentally, like in number 1, everything's going to be different. Everything's going to be incorrect. So figuring out what each side of the equation is first, that's really important. Then, like we just discovered, we're going to do the inverse of multiplying x by 2, which is dividing by 2. So we're just going to write it as a fraction over 2, and we're going to do the same exact thing to the right side of our equation. Great looking notes over here. All right. Now let's go ahead and simplify. We're going to draw a line underneath to signify, hey, this is my result after my inverse operations. Whatever's under this line right here. What happens to these 2's? 2 over 2.
1.
That's right. 2 over 2 just simplifies to 1. 1, right? So we're going to rewrite our x, and we're going to rewrite our equal sign. And what's the coefficient, or what's the number in front of our x here going to be? 1, right? It's just going to be a coefficient of 1. So it's really easy for us to say that these 2's cancel out. That's technically not the case. Canceling out is like up here, when 4 minus 4 gave us 0, right? If we get a result of 0, that's canceling out. But here we're not canceling 2 and 2. 2 over 2 is simplifying to give us 1. So just be careful of that. There's a difference between having 2 over 2 and having 2 minus 2, right? Hopefully you guys see what I mean by that. And then we solve the right-hand side. 12 divided by 2. What's that going to give us here? I heard it from a couple of people. It's going to give us 6, right? 12 divided by 2 gives us x equals 6. And if we plug 6 back into our original equation for x, we see that we get 2 times 6 equals 12. That's a true statement. We know that we're good to go, and that's our answer. So you can always check your work by plugging that number back in. Show of thumbs, how are we feeling about this so far? Thumbs up if you're feeling nice and confident about it. You know, you kind of remember what's going on. Thumbs sideways if you maybe still have some questions. Okay. Okay. All right. Let's do another example. Let's do one with a fraction, because fractions get a little bit more complicated. So let's see what we're going to do when we have a fraction. Let's say that we have 1 over 2x equals 5. So what are we doing to x right now?
Multiplying it.
We're multiplying it by 1/2, right? Now let's think about this. The inverse of multiplying by 1/2 would be to do what? Divide by 1/2, right? So if we take this 5 here on the right, and we were to divide that by 1/2, now we have a fraction inside of a fraction. Have you guys learned how to solve fractions inside of fractions yet? I don't think so, right? No, okay, good. So something like this should look very foreign to you. 5 divided by 1/2. We don't want to think about it like that because this is really confusing. Here's what we want to do instead. What we want to do is bust this fraction. Has anyone ever heard it? Does that sound familiar to anyone, fraction busting? Maybe not, but that's okay. We're going to learn today. To bust the fraction is essentially just means to break it. Right? We don't want it to be a fraction. We want it to be a whole number. So we're going to break this fraction somehow. Here's how we're going to do it. We're going to multiply, instead of divide, we're going to multiply both sides by the reciprocal. Reciprocal. R-E-C-I-P-R-O-C-A-L. We've talked about reciprocals briefly in this class. But reciprocal is just the fraction flipped around. So the numerator becomes the denominator becomes the numerator. So we're going to multiply both sides by the reciprocal. What would the reciprocal of 1 over 2 be? 2 over 1, right? You just flip the fraction around. 1 over 2 turns into 2 over 1. So we're going to multiply both sides by 2 over 1. This is going to help us get rid of our fraction and leave us with a whole number. What happens here on the left? 2 over 1 times 1 over 2. What do we get?
1.
We get 1, right? In reality, we get 2 over 2x equals, forgot to draw my line down the equal sign, see how easy it is to forget. And then 5 times 2 over 1 gives us what on the right? 10 over 1. Exactly. Again, when we're multiplying fractions, we just multiply the numerators across and the denominators across. So on the left, we have 2 times 1 over 1 times 2. That just gives us 2 over 2. But on the right, we've got 5 times 2 over 1 times that invisible 1. That's just going to give us 10 over 1. And then we have to simplify our fractions, of course. 2 over 2, as we said, simplifies to 1. We don't even need to write it. We can just write x. And 10 over 1 is going to simplify to 10, like we said. Notice how my equal sign is perfectly in line all 3 times I wrote it for this problem. Even though I didn't extend that line all the way down, my equal sign is still in line each and every step we take. That's what I want to see in your work, is lining up the equal sign, lining up the terms nice and neat, and boxing up your answers. Those are the important things here. All right, so how are we feeling about the fractions? Show thumbs. How are we feeling about the fractions? Good. Okay. Decent-ish. Okay. What time is it? 12:12. We're out of here at 12:54. 40 minutes. Okay. Let's do one last example. One last example here. Because those are all one-step equations, and one-step equations are easy. Let's do a multi-step or a two-step equation, and then we'll be done. Go ahead and write 3x minus 1 equals 5. This is like number 3 on our warm-up. So, let me ask you this. What are we doing to x? We're multiplying and we're subtracting, right? We're doing two things to x. We're multiplying x by 3 and we're subtracting 1 from that. I'm going to draw my line through my equal sign so I don't forget. Make sure you guys all do that as well. Draw a line through your equal sign just like that. Now, the real question is, do we want to focus on the do we want to focus on the minus 1 first, or do we want to focus on the 3 first? What do you guys think? The 3? Okay, anyone else say they want to focus on the 3 first? Anyone want to focus on the 1 first? A couple people, maybe people don't know what I'm looking for. That's okay too. We're going to focus on the 1 first, and here's why we're going to focus on the 1 first, okay? We're doing reverse PEMDAS. Okay, we're doing reverse PEMDAS. PEMDAS is right up there next to the clock. It's not super large, but that's okay. So we're going to start with the addition and subtraction. That's what we're going to focus on first. And then we're going to worry about the multiplication and the division. So here's what I want you to write. Reverse PEMDAS. Start with the plus or minus first. And then we'll worry about the addition and the subtraction. So if we're just focusing on the minus 1, what would the inverse be for minus 1? Plus 1, right? Not too bad. Minus 1, the inverse is going to be plus 1. Draw a line underneath to show that this is the solution to that. Just the inverse of minus 1. We did plus 1. 3x gets carried down. Doesn't change at all. We're going to keep it in the exact same place that it was. Same with the equal sign. We're going to bring that equal sign down exactly in line with our original equal sign. But what do we have now on the right? Well, we have 5 plus 1, and that gives us 6. And then here we have negative 1 plus 1, and what happens there? What happens to these two numbers right here?
0.
That's right, they cancel out, and we're left with 0. So we don't need to write anything there at all. We can just cross those out. So remember, our goal was to get x completely by itself. Is x completely by itself right now? No, not quite. We got to do one more step here in getting x all by itself. If we're doing the reverse of PEMDAS, we start with addition and subtraction, then we move on to multiplication and division, right? So what's the inverse of multiplying by 3? That's going to be just dividing by 3, right? So again, we set it up as a fraction. Divide by 3. Divide by 3. Draw a nice big line underneath. You can extend your equal sign line down as well. What happens here on the left with this 3 over 3? What does that simplify to? 1, perfect. 3 over 3 simplifies to 1, leaving us with just an x, an equal sign, and a what? A 2, right? 6 divided by 3, that's going to give us 2. Give me a thumbs up if you see how we got x equals 2 here, for example, D. Oh, only a couple people. Okay. Let's go ahead and do one more example then. Let's make sure we know what we're doing before we are expected to know how to do it, right? I'm going to do this example on scratch paper just because I've ran out of room, but for you all, just continue in your notes as normal. I'll leave that part there. Let's do example E. Let's see what we can come up with. How about, let's just take one from the worksheet. That'll be easier. Let's do y over 2 plus 12 equals 13. Anybody still writing example D? Okay. Then here's example E for you. Okay, so let me ask you once again, what are we doing to x right now? I'm sorry, y. What are we doing to y right now? We're dividing y. What else are we doing to y? We're adding to y, right? So we're dividing y by 2, and then we're adding 12 and getting 13. Okay. Let's go ahead and start with reverse PEMDAS. Because we're doing two things to our variable, we're dividing and we're adding, we're going to start with the addition. What would the inverse of plus 12 be? Minus 12, right? Minus 12 on both sides. We draw a line underneath to signify that's going to be our solution there. At this point, it should look exactly like this. What does 12 minus 12 give us on the left? 0. We can cross those out. We redraw our equal sign. Bring down our y over 2. And what do we get on the right?
1.
Just 1, right? Thank you. 1. Y over 2 is equal to 1. So, this is a little bit different from example C, because in example C, the fraction was our coefficient, right? It was 1/2 times x. But here we have y divided by 2. So let's ask ourselves, what are we currently doing to y? We're dividing, right? We're dividing by 2. Now this one's not going to be as confusing as what we did in example C. Because what's the inverse of dividing by 2? Multiplying by 2, right? So if we multiply both sides by 2, we should get y all by itself, in theory. What happens here with these two 2's? Well, keep in mind this is 2 over 1 that we're multiplying. So we multiply the numerators across and the denominators across. And we get 2y over 2 equals 1 times 2, which gives us 2 again. Now what happens with this 2 over 2 here on the left? We divide them, and what do we get? What's 2 divided by 2? 1, exactly. So we can just rewrite this as y equals 2. And there's our answer right there. So taking a look at this problem, see how the y over 2 never changed its position. I kept writing it in the exact same spot that it was in above. Even though we had that blank space there from where the 12s canceled out. I want you to keep that blank space and make sure everything is staying in line. Okay? Equal sign never moved. The number on the right stayed in line as you went down. And it helps you see exactly what you're doing there. Okay? What questions can I answer about this question or this lesson in general? How are we feeling now? Show thumbs just based on what we talked about, these 5 examples. How are we feeling now? Okay. Good. I appreciate those of you who are still with me. Let's get this worksheet passed out, shall we?